Let's talk about one of the most important rules in differentiation. Now, just because it is important doesn't mean it is complicated, or if you think it is, I'm gonna make it very simple. But before we jump to the rule itself, let me show you why we need it first. Well, if you have seen this video right here, I have gone through all of the formulae in differentiation and integration, but this function right here doesn't seem to fit in any formula because we have a product of a polynomial function and a trigonometric function. And that is the problem there, because it is like a mix of multiple types of functions that cannot be simplified, which is particularly a product of two functions or more. So we need something called a product rule. It is just d by dx of u times v. First, you differentiate one of them, keeping the other the same, and make them a product. So let's say I differentiate v first, so u dv. So a v prime here means the derivative of v, or what we get after differentiating v. So this is u dv plus v du. So here this time, differentiating u multiplied with v. Perhaps the most popular way of memorizing a product rule here is just by going u dv plus v du. So let's apply this to the aforementioned example. We wanted to differentiate x squared sine x, again letting u be x squared and letting v be sine x. So u keeping the same, we get x squared. V prime here means that we need to differentiate sine x, and differentiating sine x we get a cos x. So I just write here cos x plus v, which is sine x, so we write down sine x, and differentiating u is x squared, so it's just differentiating a polynomial function. We bring the power down 2 and then the power subtracted by 1, so that's going to be just x. And that is it. You could simplify it a bit further, but that is the key result. Let's try another example. Differentiating 10x over x squared. Now, those of you who've already known quotient rule might argue that this is probably more appropriate if we use quotient rule. But product rule is like a bigger picture. We can actually apply a product rule to anything a quotient rule can do, but not necessarily the best way. It's just that we can. Of course, quotient rule is perhaps more suitable in particular circumstances. But you might wonder here, because 10x is not multiplied with x squared. Instead of having x squared down here, we can bring x squared up here. And let me just rewrite the question. So this is x to the minus 2 instead. Now the rest is just easy, because now we let u be one of them and v be the other one. So u, we write down u, which is tan x. Differentiating v, which is x to the minus 2. We bring the power down minus 2, and then x to the power 1 less than before, so that is minus 3, right? Because minus 2 minus 1 is minus 3. And then the other part is just v, which I'm gonna write down as x to the minus 2 here. Differentiate u. So differentiating u, which is a tan x, we get sec squared x according to the formula. So that should be sec squared x, right? And now the rest is just simplifying. For example, you might want to factor x to the minus 3 outside everything. So I might have x to the power of minus 3 outside. And in parentheses, I have a minus 2 tan x for the first group. And then here, if you factor x to the minus 3 out from x to the minus 2, you're going to have to get x left in that term. And sec squared doesn't do anything, so I can just keep sec squared like that. That is just it. You see, it is very simple. Now, what if it is not just a product of two functions? What if it's three functions? Okay, let's differentiate. Let's say I have x squared here, sine x here, and then now we're gonna bring another kind of function, the exponential function e to the x. Perhaps the simplest way to do this is just grouping them up. So we can group this up to a u, and that would just be left as a v. So we just go u dv and v du. So u x squared sine x dv, differentiating e to the x, we get e to the x. So I'm just going to write e to the x plus the second part v du. So I'm going to write v here. And because this part right here is also a product of x squared and sine x again, so we have to do the product rule inside that u. Now here are other u and v that are not to be confused with the earlier u and v. I'm gonna let u be x squared and v be sine x. Inside the parentheses here, u dv, we differentiating side, we get a cos, and plus v du, we get 2x, right? So it's just a product rule inside a product rule. basically. And of course, if you want to simplify everything here, you can, but that is just again the key result from using a product rule twice maybe. I hope I have made it simple enough for you to understand easily. Again, if you didn't quite follow in terms of the differentiation formulae, I recommend you check out this video before you come to this again. If you are totally okay with this video should be the next one you definitely should watch. I'll see you in there. Don't forget guys, keep studying. Bye.